Peace. Are we live? I'm having some strange technical issues here. Took forever to get the stream rolling. Now it looks like we're good. Appreciate you guys. We're going to continue on with the introduction to transhumanism and cybernetics today. As mentioned in the latest Future Shock episode, I'm going to be covering that entire 6th gen clip. I played about a good minute or so of that clip, and we're going to go over the entire clip. It's about I think it's about 30 minutes long. I thought it was longer than that, but it's about 30 minutes, and we're just going to walk through it and see what it presents. It's a really important look into this new transition as far as man's image. Now, on the lecture series, we've been focusing, at least with this tail end part of the series, we've been focusing on the changing image of man. So it's more of a, let's say, a worldview based, psychological, but also philosophical view of man changing into something different, evolving, which is inherently the transhumanist philosophy. Man isn't finished evolving. Man doesn't end or stop with Darwinism. He continues to churn out his next version via his intelligence, his reason, but of course with his technology. And as we've been looking at this view of changing images of man, and of course changing the culture's image of man, and we've seen this through whether it be the trans situation, right, or comic book Marvel worlds, and many other examples that we've talked about here. So really the goal is to change society's view of what makes a human, such that as they roll out these new technologies, of course, this new infrastructure via industry, people will no longer be attached to this preconceived notion of what makes a human, especially that traditional preconceived notion that connects man with God, that creates creation with creator, that gives creation some type of responsibility or accountability to its creator, right? That gives creation, man, some type of inherent transcendent meaning and purpose that sets it apart, right? This type of Anthropocene view of man being set apart and above life on earth as far as the beasts of the field, right? Man is to subdue the earth. Man is to be fruitful and multiply. This very Christian-based view of what a quote-unquote human is, right? That is transitioning into this new transitory view. And they've been trying to do this philosophically, but today I want to focus on this augmenting human potential video by Nokia Bell Labs, because I think it presents a very good example of the industrial aspect of this. Not just necessarily changing the image of man in our minds and in our hearts, but this is how the image of man is applied. Its new transitional, I guess, representation is applied to technology, is applied to industry. This is how industry, or I guess what we could say, is applied transhumanist technology, right? Taking human beings, putting them in a new type of transhumanist ecosystem. And this is a very, very good example of how that works as we go into 6th gen. So this will be focusing on 6th gen. I understand most people are dealing with the 5th gen technology, but that's almost old at this point. It's here, it's done its thing, but the goal between 2025 and 2030 is to get us right into the 6th gen. So let's look at this scenario here and see what this stuff is really about and how it relates deeply to transhumanism, especially as an industrial example. Okay.
Thanks for having me. I'm going to talk to you about how 6G will provide the essential infrastructure to augment the human capabilities. Human capability.
augment the human capabilities. Okay, so the way this is going, well, the way they are selling it is, it's really interesting. Hold on, let me pull up the camera here. There we go. It's really interesting because it's selling us the philosophy of transhumanism, right? We're going to augment your capabilities. Now, this is, it almost goes without saying, right? And I think that has to do with the success of convincing society and the mass populations that our old world, our traditional view of what makes a human, what makes a man man, is no longer viable in this new future, right? In this new techno-futurist dream. These old, very naturalist, physicalist, vitalist ways of looking at humanity no longer fit in this new technological direction we're now all going in. So since technology is changing, society is changing, with that must change our view of what makes us human. Okay, so it's like this. Don't worry about it. Nothing to see here. Just follow the technology. And augmenting human potential, key term potential, is a smart sales point, because what it does is it offers up the let's say idea of enhancement, right? Efficiency, all of these futurist and technocratic terms that we're very familiar with. So it sounds like it's going to broaden our abilities, right? Give us more opportunities, and of course more abundance. So let's look at this here.
As in enhancing our ability to handle proximity.
Let me run it back real quick. Now, it's going to be sold industrially. Okay, first off, Elon Musk likes to sell it more from the view of, we're going to solve disease as far as like blindness and immobility, and other things like loneliness, and even truth seeking, right? Information gathering. But there's also this view that says another goal of this technology is not just to appease the individual or even the human species, but let's enhance our industries. Let's create more efficient, more sustainable infrastructure such that our lives will be easier as a response. Okay, so another one of these sales points is, we're making better industry, so we will have better lives as an outcome. And none of that is guaranteed. There's no data to suggest that that is the case. And in fact, I will be arguing, as I have in the past, that it's quite the opposite. In fact, we'll be seeing a lot of negative outcomes opposed to the positive. And again, this speaks to this transhumanist futurist view of a naive optimism, right? Where they just have this naive view that the most optimum outcome probably will be the case. And they tend to lean on probability more than possibility, when it's actually the other way around, from my view. And the what's worse is they don't have actual data to back up that probability. It's kind of all like fantasy. But again, we are, in a sense, stuck in this futurist dream. We're living out the dreams of these types of technocrats, if you will.
Capabilities. Human capabilities as in enhancing our ability to handle proximity, our ability to handle and create knowledge, and enhancing our productivity overall. So let me start with this view here. This is inspired by the book of Harari on Homo sapiens, who makes the point that our human capabilities have been shaped through human evolution.
Now, you heard that. Who is he referencing? Mind you, this is the representative of Nokia Bell Labs. This is big tech. This is infrastructural power. This is, whether it be Oracle, Microsoft, Amazon, all of these, Google, right? All these massive infrastructural, technological systems and industries that provide us day-to-day living, let's say, services, okay? These people are extremely powerful, extremely influential, because now that we live in a technological society, what we do day to day is technological, or better, mediated, right? We live through mediated processes. Most of the things we do today require some type of screen, require some type of Wi-Fi connection, essentially some type of device within that system. So these people have a lot of pull and a lot of power. It's important to understand what these people believe in. It's important to understand their worldview. Where are they drawing their conclusions? Where are they drawing, or should we say gathering, their influence and their motivation? Okay, he appeals to Harari's book, Sapiens. Now we understand who Harari is. World Economic Forum, also an atheist, not to mention part of the Rainbow Brigade, as well as a what is this, like a moral nihilist, right? So it's important to see where they're gathering their views from, because they're all satanic. They're all from the position of anti-God, anti-human. Very important to understand that the people building our infrastructure through which we will be living our lives day to day hold these views.
Basically to become a hunter-gatherer. But over a couple of thousand of years, our human environment has changed significantly. We are now living in an urban environment, and the number of people that we deal with has enormously increased. The density has increased from 1 person per square kilometers to 100 per square kilometer, and in urban environment even thousands of people. We were shaped as a hunter-gatherer to work and live with 150 humans. So still today, this is the amount of people that we can have resonant, effective relations with. But the number of people we interact with has diabolically increased to 100,000 of people. In a city, in a company like Nokia, where I work, 100,000 people are an email click away. But these are not the same resonant, effective relationships as the 150 immediate.
Now, this is a very, very key point, and it's a frustrating one to deal with because there's reason behind it. It's very rational. Again, a lot of these new technological directions and movements are extremely rational and will seem like good logical directions just based on our given scenario. And he demonstrates it here. Sure, we have a lot more people in our lives. We're in a lot more, let's say, dense environments, especially in the major cities. Now, this is a big problem as we move into this idea of smart cities, as we move into this new kind of super modern metropolis, where they want to smash everybody in these small 15-minute cities. We have all of the examples. I mean, Dubai is a good example, and many others. The Line, etc., that are already failing. By the way, these new smart cities, they're already failing. The best way for them to I'd say succeed is to start at much smaller scales. Okay, but they're very ambitious. They have billions of dollars behind them, crazy technology, and it offers them the opportunity to push faster, acceleration, and to go in a sense to be more zealous, to be more confident than they actually should. And this is extremely problematic because it's testing technologies and new ways of life live, experimenting on human lives and human families and the development of the human species, right? So it's unfortunate that they're saying we're growing so much, we have too many people, and with all of these people, it's very difficult to have sustainable connections and to run sustainable ecosystems, infrastructure, industry, etc. This is true. This is very true. Okay, so the solution to the problem is more connectivity. Faster connectivity with more, let's say, nodes or sensors to connect. Hence 6th gen, where the environment is a sensing entity itself. With that level of sensing capability, with that level of networking technology, we can have billions of people and be able to interact and connect to each other much more successfully because of this technological networking systems. So these are the solutions, and it's rational. More people, more connections. We need better technology to connect us better. The problem is, Should we live in these types of environments? Should we be pushing ourselves into these bigger cities, more stack and pack? Of course not. But unfortunately, many people are being pushed this way due to economic environments, or should I say, the economic situation we're in, right? And this is the part that's so frustrating. There's very little the general population can do, because essentially we're driven by the economics of things, right? Where you live dictates who you become in many cases. But a new problem now is that, well, we have the internet, we have social media, we have all of these new outlets to give us identity, to shape who we think we are, but it's all hyper real, it's virtual, which creates a whole other issue psychologically. Let me not go into the tangents of that, but I find it very interesting that we're put in a position where to argue against this would almost be foolish, right? Because, hey, we need this technology to sustain such massive populations of people. Hence, the only really good option is localism, is to decentralize, let's say, living quarters of populations. Instead of going into these massive cities, we need to create smaller dwellings and quarters in which people live. Again, that has to do with high level distribution of architecture and design, and of course industry. And that's just a giant mountain to climb there. So we are put in this situation where we have very little choice, and it's going to take people figuring out what's being built around us, talking about it, speaking out about it, and informing enough people such that organized efforts can be made, and possibly people could join each other and resist this movement. But this is the opening argument. There's too many of us, so we need to adopt these technologies to make our social systems work and function. Right now, the problem is there's a requirement for that system to function and to work properly, and that has to do with biodigital integration. It also has to do with removing human and personal autonomy, right? Privacy. All of these things are out of the window. So it's a trade-off. It's like, sure, we'll get better systems, but you'll have to give up many aspects of who you are, as well as your human makeup, right? Hence the importance of understanding that this is essentially all transhumanist directions here. Even this type of infrastructural stuff, it feeds into the transhumanist view. Now let me play this thing and stop talking so much. I'll try my best not to pause it. I'll try.
Also, actually, the whole globe is within reach. You heard about the expression of 6 degrees of separation. I reckon actually in our profession, if you look on LinkedIn, we're only 2 or 3 degrees of separation away from each other. So we need help to handle and have more effective proximity with the people we interact with. Second is about knowledge. And the knowledge at the times of the hunter-gatherer pretty much stayed constant for thousands of years. There at that bay, you can go for fishing, that bear is dangerous, these berries you can eat, and pretty much that stayed constant for thousands of years. But since the Renaissance, the human knowledge has increased more than exponential. The doubling period has actually accelerated enormously.
Knowledge shall increase, right?
In the Industrial Revolution, it was a few decades that the human knowledge increased. A few years ago, it was within a year, and actually now it's doubling every 12 hours. And I'm really talking about knowledge, not just about collected data, but the really learned experience. So we need help to handle that. And the human brain did not evolve in the same way. Actually, what this Ebbinghaus curve says, you will have forgotten most of what I said within a month from now. So we need help.
So again, this is very Muskian, if you will. This idea that knowledge has increased so much. There's such a demand now for information that we're going to have to either merge with a machine, some type of AI, or incorporate some type of mass data collection AI-based system, which is essentially what 6th gen blockchain Web3 technology is all about. And it's supposed to be a type of solution to this problem of knowledge. Knowledge has increased so much, we forget everything. We're not capable to let's say, not just generate, but I guess understand and be able to wrap our head around all of this information. It's nearly impossible for the normal human to process this level of data. So we have to have these new technologies. Now, the problem is and this probably sounds weird today, but we don't need all of this information. Do you see how industry and their products and their services and their technologies are foisted upon the population? And with that comes the transhumanist worldview, right? That's systematically changing who we are. Unbeknownst to the general population, people think this stuff is cool. People think this is just technological evolution, right? But in fact, it's a type of human evolution, transhuman evolution, because as the technology increases and changes, we are increasing in, well, we are changing in other ways. I'd say we're decreasing in many human capacities, but we're increasing these mechanistic capacities that he's speaking to, right? More knowledge and more processing power doesn't fix man's fallen nature. It doesn't fix man's spiritual elements. It doesn't fix man's heart, right? It appeals to man's mind. And again, this is extremely satanic. When we think about this, it's a very Luciferian direction. It's gnosis, it's Gnosticism, right?
The good thing about this Ebbinghaus curve is I can reuse slides and you still hopefully find them interesting. Actually, this particular figure on productivity, I have used 2 years ago at the very first 6G summit in Levi in Finland, where I made the point that we will use ICT to enhance the productivity. Productivity as in effectiveness of manufacturing, producing.
Was I muted? Ah, my goodness, I was muted. Ah. Oh my goodness, that's frustrating. So basically, unfortunately, what they're selling here is access under the guise of you will have all of these new technologies that will make your communication better, that will make your life more efficient. Unfortunately, what it's actually doing under the guise of those things, it's giving these corporations direct access to our person, biologically speaking, but also access to our ideas, our minds, access to our behaviors through mass data, but also access to our relationships, okay, those who we communicate with. It's under this false guise of productivity, you know, but really essentially it's about these industries having more and more access to human behavior and human control.
Goods, but pretty much everything we do as humans. So it's the goods that then are used. The point that we will use ICT to enhance the productivity. Productivity as
and I had mentioned, I think I was muted, I was defining ICT, which is information communication technology. And this whole ICT, we're going to fix the world with ICT through information communication technology. But actually, as I stated a second ago, it just gives these corporations more access to human behavior.
in effectiveness of manufacturing, producing goods, but pretty much everything we do as humans. So it's the goods that then are used in leisure time to play, to learn, and actually to then become more effective and more efficient in the next cycle, cycles of a week, cycles of a generation. So productivity as in outcomes per unit of input, humans, surface, raw material.
Input, output. This is cybernetics. So this is integrating human behavior, human populations, but also human social networks or society into cybernetic systems. This is precisely what this is.
And a good measure of human productivity is the GDP. And this is a graph from the book of Robert Gordon, Rise and Fall of American Growth. And it shows that in the first half of the previous century, the human productivity growth year over year has increased thanks to inventions of the second industrial revolution like transportation, car, petrochemistry, steel. So it went from 1% to more than 3%. But in the second half of the century, it declined again. The growth declined again to less than a percent. And that despite the invention of the internet, despite the emergence of mobile networks. And so what is the reason? Well, it's because the network was designed for consumers. We use the network to watch video, to do shopping, so not very productive. And so we need to change that. But
as if more technology will change that. I think what they're afraid to admit is once you give human populations this level of technological interactivity, the productivity decreases because of many things: information glut, right? Algorithmic capture, as well as issues with the dopamine and attentional deficits. Pleasure seeking, living out vicariously through the hyper real, right? All of these different experiences that the general population has, all of these things the general population has been dealing with for, let's say, at least the last 10 years, has of course lowered the productivity. And this is, well, I'd say for these corporations, it's a good thing, right? They want people to be still, immobile, and giving up their attention, right? Because this feeds data to artificial intelligence, as well as it gives predictability of mass populations. So he realizes we need to fix this. The more technology we've received, the less productive we've become. The worse our relationships are. We need to fix this. And how are we going to fix it? More technology, more connectivity, more abundance. Sure.
Since my first talk at the 6G Levy Summit, COVID happened. And during COVID, the amount of e-commerce has peaked by several tens of percent. So within 6 months, we have achieved a rise that otherwise would have taken more than 6 years. So we've seen that having an e-commerce infrastructure has been essential to keep our economy going.
So now we're in the progress trap to where we have to keep accelerating e-commerce and connectivity to keep the system going, right? And it becomes a snowball effect. Let me reference the chat here. Shout out to you guys. Wisdom333 says, agreed, however, people will still go for it out of convenience. And so long as they can keep their comfort, most think it's lunacy. The rest have a they do that anyway, so oh well mindset. Precisely. And this is the unfortunate aspect of it. Hence, a big part of this work is to try to bring some understanding, at least awareness of these developments, so people can maybe have a second thought, maybe rethink some of these views. But again, it will always boil down to a type of convenience, because we have been pushed into the corner of learned helplessness, and people are stressed out and anxious and don't want to deal with any extra trauma or pressure. So convenience and ease and efficiency is only going to be advantageous and look like some type of incentive. So you're correct. Yes, Streaming Online says, I seen this a week ago. It's crazy how they put it out there for all to see. And if you tell people, they think you're crazy. Exactly. They think you're absolutely crazy. And even if you show people these things, sometimes they'll be like, oh, you guys are just exaggerating. Yeah, okay. More censorship, more psyops, more invasive methods of control. Absolutely. Censorship with an S. I like that. That's what it is. That's what this 6th gen is going to bring. We thought 5th gen was bad. 5th gen is actually a low level kind of almost archaic technology at this point. If anything, it seems to cause more, let's say, harm as far as one's wellness or well-being is concerned. But this next technology is going to be moving into the terahertz band, which is a little more safer molecularly or cellularly, but provides a lot higher level of connectivity and speed, which just gives them more power. So it may have less of a biological negative effect, but it will have an extreme, let's say, enhancement of corporations, industries, banks, etc., governments. It will give them an enhanced, let's say, an enhanced level of data management, which puts us all in a precarious situation.
Now, this was only possible because the investments to roll out that infrastructure happened already more than a decade ago. And so that realization will...
Yes, CV19 triggered unprecedented success in digitally mature industries. You see that? And that's why we've been saying this even in 2020. We were saying this is about acceleration. COVID, the whole quarantine, that accelerated massive digital systems and industries. And here we are.
Stay, and we will see an increased and an accelerated investment in ICT. So there's basically two industries that we can distinguish. There are the physical industries, think of the retails, think of transportation, mining, and then the digital industries, think e-commerce and banking. Now these digital industries are the ones that have the majority of the ICT investments, more than 70%, although they're only 30% of our economy. And they are at a healthy 3% growth year over year. The physical industries, they are the largest part of our economy, more than 70%, but the ICT investments are at 30%, and they are at a less than 1% productivity growth. So the whole idea of Industry 4.0 is to bring ICT technologies to enhance the productivity also in the physical industries.
And we're seeing this pushed heavily through, say, BlackRock, for instance, who, I guess I shouldn't be surprised, but Trump has, I believe, brought on Larry Fink. Can you believe this? Can you believe how all of this is panning out? So BlackRock, as well as these other giants, they're very concerned about, as he's saying here, bringing ICT to maintain this new market of natural assets, where they are terraforming the environment, opposed to the ICT, the digital industries that are terraforming human biology, but also human psychology, right? Behavioral patterns, etc., worldview warfare, ontological warfare, what have you. So this is a perfect example of my concept, terraforming the environment, the physical, which would be the physical industries, and terraforming the body or the mind of humanity, which is in the digital industries, under the guise of e-commerce and banking. But then when we look at what economics essentially is a branch of psychology. When we study economics, we can understand behavior. Now, this isn't to say I agree with Homo economicus, which is extremely flawed, which is under the impression that human beings are essentially rational. I say it's quite the opposite. Human beings are essentially irrational because we're emotional prior to logical, but that doesn't mean you can't learn this from economics as well. It's just it's a flawed model. But let's continue.
And so with COVID and the experience and the realization of the importance of having automation, remote access, we will see an acceleration of investment. So you see the red curve already. This is what I showed you earlier of the e-commerce infrastructure, but then also the physical industries, the lead physical industries like retail and transportation will accelerate their investment. So you see the inflection point, that purple dot, will happen 3 years earlier than initially planned. So this is based on an analysis that Bell Labs Consulting has done. And also the laggards. Think agriculture, for instance. Also there, if that inflection point will happen already this decade. And so we see an inversion of ICT investment now by 2030 in the physical industries by 65% of the total ICT investment. So proportional to the size in the economy.
He speaks to agriculture, food systems. Very interesting how we're moving towards these new bioengineered foods. Of course, they're using zoonosis and zoonotic spread to phase out animal husbandry, right? And the whole concept of let's say, cattlemen and ranchers and local farming, moving everything into an industrialized, mass-scale engineered food system that will require these ICT technologies. And as you can see, though he's not saying the details, this is precisely what he's talking about, moving everything towards a type of circular economy that's rooted in highly sophisticated ICT technology, essentially blockchain and high performance artificial intelligence mixed with new hardware, right? Robotics, etc. This is a perfect example of a type of transhumanist transition into a new bio-digital, cyber-physical future.
Now, it's also important to realize that these investments will happen this decade, before 2030, before the commercial rollout of 6G. So it is very important to then think, okay, if these are 5G investments, what is the new application, the new use case that we will design 6G for? And in order to understand that better, it's good to have a look at the past and the present. And every new generation, about every decade, has optimized the use case and the application of the previous generation, enabling it to do it at better performance and at lower cost. So 3G has improved the voice services of 2G, and as a new application, provided high-speed internet access. So the new application in 4G was then enabling higher speed video, so downloading YouTube and social media, and also machine type of communication, while at the same time cost optimizing the internet access and also enabling now zero cost voice. In 5G, the new use case is industrial automation, while we improve and also on the video and allow for real-time video conferencing at scale. And now the question is, what will be the defining use case for 6G? It's important to have that new use case because that will drive the direction of the new specifications, influence how we design the future network, and also be an inspiration source for the research in that direction. So, and our thesis is that it will be a massive deployment of sensors, massive deployment of AI, and that will allow us to connect physical worlds and human biological worlds with digital twin models in the digital world.
Absolutely. Mass distribution and diffusion of sensors. Now, something we've discussed in the past, and I will be presenting a lot more research on this as we dig into this transhumanist industrial angle. Biological sensors appear to already exist at, let's say, the deployment thereof, right, in the human population. COVID having something significant to do with that. Okay, so these ideas of, he's speaking to the ideas of environmental or external sensors all over environments, so such that we can sense activity. But we've discussed this here, and I have evidence that we already have these types of sensing technologies interbodily, which will create an even, let's say, more successful connectivity between the bio and the digital, as he describes here, bringing the two together. And if we think about it, it might make some sense why certain technologies were rushed and pushed on populations with very little thought, because there was actually a future view in mind. There was a, let's say, a preconceived plan, another aspect of the rollout. Multifaceted, sure, there are a lot of moving parts, but I think this is something interesting to consider. And when those technologies are needed, if people's minds, hearts, thoughts will be so far removed from that situation that happened, say, by the time 8 or 9, 10 years ago, it won't bother them anymore. And when they consider the new connectivity and convenience that they now have because of this network system that has been integrated biologically, they might look at that as some type of good thing. Well, hey, look at all the cool stuff I can do now, and I seem to be okay, right? Something to think about. 6th gen, connecting worlds, massive scale AI and sensing, holographic video. These things speak directly to Web3, metaverse, etc. Zero cost data, zero cost video, massive MTC, low cost industrial IoT. So as you can see, this new tech is going to be loved and adored by the general populations, because it is going to bring them more access, more abundance of data, and definitely more content for free at crazy speeds. So this stuff is going to look like a god. In fact, we could possibly see some type of antichrist built out of this, Gollum, if you will. But that's just an idea. I know it's controversial. Many people have different views on what the antichrist is. But as they build up these technologies, especially with this whole artificial intelligence as sentience, and bringing abundance and fixing all the ills and problems of humankind, it sounds pretty damn close, if you ask me. But let's continue.
So let me explain that a bit more. But before doing that, in the theme of the proximity, productivity, and knowledge, most of these generations have addressed the augmentation of human proximity. It's actually only with 5G that we really started addressing to improve human productivity. And then with 6G, we will start improving also our capability to handle and create new knowledge.
Interesting, right? So proximity, huge change with the internet, right? Changing the proximity of communication, time, space, physical presence, right? So with, say, 2 to 4G, we've transformed proximity in that we don't have to be in face-to-face or in the same room to communicate. We don't have to be in certain locations to see what's going on, right? So proximity is a big change. Into productivity, right? With 5th gen, we're able to connect and interact and download things easily at such great speed in the palm of our hands, so we can do more, right? It is my argument that as transhumanism seeks to put doing as the most important thing at the expense of being a key component of your humanness, of your God-created self, body, what have you, we move towards doing as productivity, right? Gaining knowledge, being as smart as a computer, all of these very mechanistic, machine-based views. We moved into productivity, into gnosis, or let's say omniscience, right? As we get into 6th gen, where we will have exorbitant amount, some would argue infinite amount of information with infinite amounts of storage capabilities, right? Giving everyone their own little personal God in their pocket, as some type of AI assistant, if you will. So if you pay attention to what this is building, right, it's like proximity, you think of presence, omnipresence, right? Productivity, the ability to do things, the ability to wield technologies. Productivity, the ability to change through doing, or dominance or power, right? Omnipotence. And if you think of knowledge, you think of knowing vast information, possibly with enough sensing capabilities and ubiquity thereof, you can know everything there is to possibly know, hence omniscience. So with this, you can see the breakdown: omnipresence, omnipotence, omniscience.
And now you may question, yeah, wasn't the high-speed access to data with 3G already improving knowledge? No, it only improved the proximity to knowledge, the access to knowledge, whereas now in 6G with AI, ML, we will truly have augmentation of our knowledge creation. So here is another way of looking at this. So 5G has improved the connectivity between humans and machines. In 6G, thanks to the massive scale deployment of sensors, we will have a much richer connectivity of the physical world, a richer connectivity of our own biological world, and then twinning that with models in the digital world. In the digital world, where we then apply AI ML to get a better understanding in real time of what is happening in the physical worlds. And that is important because these digital twin models, for instance, allow to transport the model. I can be transported and be with you as if I were there in a holographic experience. These digital twin models allow to understand and anticipate needs, simulate possible outcomes, and then take decisions back in the physical world for more optimal productivity. Same is true for our own biology. These sensing capabilities allow for better healthcare, but it also makes our interaction with the world more intuitive, enhancing the human-machine interface.
This is so key, right? Because to the futurist, this sounds like, hey, that's cool. To the general population, the ignorant masses, the layman, this doesn't really make any sense to them. Like, they don't understand what that actually means. What do you mean more intuitive? The problem with this is what he's describing here is a new type of intuition, right? That is, it's very similar to the concept we've discussed in the past, extended mind or distributed cognition, okay? So this new intuition is about a codependency, intuition based on a type of contingency, right? Our intuition, our ability to know, is contingent on a source of data, but also a networking connection, some type of network system, as well as some type of database, right? That is integrated with our biological world or our mind at some point, and we'll be able to have what he says here, a new type of intuition, which would suggest it's completely inhuman, right? It's no intuition of a human type. It's an intuition that is rooted in this new biodigital system. Now, once people realize this is what they mean, they'll discover, well, what do you lose in that process? What you lose is human intuition through a disruptive process. This technology imposes data. It imposes through data, it imposes ideas. It imposes perspective, it changes perspective, it influences behavior. What it does essentially is it disrupts one's natural ability to intuit, one's natural intuition. That's wild when you think about it, because this is purely transhumanism. It's completely augmenting one's intuitive capabilities by adding on integrated systems that impose messaging, information, as well as frequencies on the individual, right? It's, when you really dig into it like this, it's rather disturbing that this is being considered as a normal way of life for every person, turning everybody into Homo sapien 2.0.
Let me explain the importance of these digital twin models a bit more in detail. It's actually already happening in 5G. So there are already digital twin models in factories to keep the state of the machine, to anticipate the need for maintenance or repairs. And actually also in a wide area network, we see the concept emerging of digital twins of cities, and even at a precursory state, digital twins of ourselves with recording of Fitbit data and health apps. Now, it's already happening now in 5G, but in 6G it will happen at a much larger scale of sensors and AI deployment. So that will have an important impact on the architecture of the network. So you see here a simplified view of the network with the access part, the anyhole to the edge cloud, and then the IP optical transport to the centralized cloud. And now, looking at the deployment of these many sensors, they will create an enormous amount of bandwidth to upload in real time data to the AI/ML digital twin models distributed over that infrastructure. And think of these digital twin models as 3D maps with layers of parametric information, but then also more abstract, self-learned models in AI/ML where we continuously update the weight factors within the AI model in one location, but also in real time across locations.
Think about the level of algorithmic capture in this kind of scenario. Everything is being driven by algorithm, even human behavior, through input, through information. We essentially, everyone plugged into this type of system is taking cues, is being informed by algorithms that these companies, these individuals are tweaking. That's, in a sense, it's remote population-wide mind control when you really dig down to its root. This is remote mind control at a population level. I mean, it speaks directly to what Comte was trying to achieve with a type of science, a sociology based on science, right? Like applying materialist positivism to the sociological. This is Comte's dream here. It's really fascinating to see it actually coming to fruition. It's crazy at the same time. But what's worse is they're just rolling this stuff out because it's industrial. It's an aspect of our future industries and science. And in the transhumanist world now, what we've discovered is humans play, let's say, a supporting role, or we sit in the back seat with technology, science, and industry as the driver, right? So essentially changing us with it as it changes. Who signed up for this, right? I call it digital domestication. We're being domesticated into these new integrated digital systems. We're being transferred into these bio-digital systems where we're not really persons, with meaning and lives and views and families, right? We're just units of operating biological processes that are accessed by way of digital technologies and, in a sense, corralled to and fro.
So this will have an enormous impact on the utilization and the bandwidth requirements of the future infrastructure. Let me now illustrate that a bit more, how we use these digital twins to optimize productivity. So first, in an example of farming.
Here we go with the food supply takeover.
So this is an example of urban farming, vertical farms, where we reuse warehouses to install vertical farms. And so that enhances the productivity because it's close to the people that need to produce the crops. So we reduce the transportation time and the need for refrigeration from 5 days to almost 0. And then you have more fresh produce delivered. We also improve the productivity, the use of water by injecting the water really at the roots of the plants. We also reduce the lifetime, the growth time from 40 days to 12 days by optimizing the light cycles.
So think about it. Yeah, this optimization, acceleration, efficiency, high yields, scalability. You get all of these things with this new type of technology, but what else do you get? I would argue you get a type of centralization by way of technology. You want this type of, say, food production, you have to rely upon these systems, these technologies, and the industries that provide them, right? The industries or the corporations that supply the networking systems, the AI, the technology. It ties us to a type of codependency with the technologies, right? We can't just go out there and be green thumbs and create farms like we always had and grow food and raise animals to eat. See, now it's all being centralized in a type of fourth industrial system where now we rely upon these people and their technologies just to, in a sense, survive, right, or subsist.
And then the overall productivity per square meter also improved by almost a factor of 400 because we are using these multiple shelves, optimize the fertilizers, and actually it's a very protected environment. We actually need zero pesticides because there's low risk of contaminants. So in order to understand that use case better, we have built our own small vertical farm in Bell Labs in Murray Hill in New Jersey. So you see here a view of our vertical farm setup. In the upper left, the real world view.
How sterile does all of this look? For me, it's technological innovation, sustainability, considering food that is, sustainability, technological innovation, at the expense of nutrition. I highly doubt these technological foods will be nutritious, right? And let's also speak to the people behind this type of technology. Are they eating right? Are they living healthful lives? I don't know this guy, but I highly doubt he knows anything about nutrition, yet he's promoting technologies that are going to provide the earth with foods. It's really disturbing, just like you see computer engineers talking about health and what people need to be putting in their bodies. It's absolute madness.
At the lower left, you see actually there's a drone flying in between those shelves, and the purpose of that drone flying between those shelves is to inspect the growth. And you see the fisheye view from the drone perspective. And then on the right-hand side, you see actually a simplified digital twin model of that setup. And you see how we remotely control autonomously from a server the flight path of the drone. You see how that the drone, thanks to localization techniques, follows a predefined path with depicted with the green lines. Now the whole purpose of that drone flying there is really then to create a digital twin of the growth itself. And so that you see on those next view. So you see the view, the rare view or raw view of what the drone is seeing. You then see how we inspect by leaf segmentation in the lower left, how we looked at the growth quality by just looking at the colors. And then also you see how we are able by image classification to inspect the growth quality. So that is one example how we create a digital twin model of the physical world in order to optimize productivity in farming.
So it's important to look at the industrial applications of digital twins because it is precisely the same type of application for humans. So as they create digital twins to manage and remotely control industrial processes and functions, they will do the same things with human beings. That to me is just mind-blowing when you really think about it. So why would anyone consider this? When we see how they start selling it to people, we'll understand why people accept it, because it will be through some sense of convenience, and they're going to have to achieve some high level of trust. But I don't think that's even necessary today. People, as mentioned earlier, people are so just consumed by the day-to-day. They're lazy, they're incompetent. Learned helplessness has ruined an entire generation. So we're to the point now where people aren't even in the position to think on this level, right? Because there's just too many things impacting their lives. Not to mention, they're just distracted, just full on distracted by so many things happening and going on. Politics, culture, media, etc.
Here is another example. So you see here the view of the conscious factory in Oulu in Finland. This is where we produce our radio systems. And here we apply these concepts of industrial automation using 5G and digital twin to keep the state of the factory. And you see humans in the factory, but they're no longer doing the production. They're no longer doing the manual tasks. That's all taken care of by the robots. The humans are there to supervise and to do the creative product improvements.
That's the sales point. See, we're going to replace the mundane with AI and robotics, freeing up humans to be creative. Well, first off, how many are really going to be necessary when there's so many robots and AI running everything? It will be a handful. What happens to everybody else, right? Really, really interesting how they do this. That's why it's so important to recognize the industrial applications of this, because it's a foreshadowing of things. Now, check this out. Hey, honestly, this type of technology seems to be very advantageous for industry, especially when we consider, managing all of these high processes and functions. So for me, it's not such a horrible thing to have certain types of technologies that give you the opportunity to, say, remote manage or remote control. But why are you trying to apply this to human beings and human biology? You see, that's when things start looking pretty creepy. You could have just stopped at the industrial. This helps us build things faster. It keeps quality control in line. It allows us to, avoid a lot of mistakes and error. Okay, cool. Now they're trying to apply this stuff to the body, to the brain. That's how you know this stuff is all about some massive shift, some bigger project. It's just not about economies and, products and services. It's much, much deeper than that. This is on a spiritual and existential level.
The production improvements. So we do that thanks to the digital twin models. So you see here how that is our knowledge engine to keep the state of the production of the stock, and then also how we use 5G for remote control of robots, for the navigation of robots. And these automation concepts have helped to enhance the productivity. The lead time has improved by 80%. The overall productivity has improved year over year by 30%. And because we're taking out the human error and allowing for intelligent video inspection, we have reduced the number of defects by more than 50%. So overall, an enormous improvement also of the quality. So these are two examples how we use digital twins as a perfect knowledge engine to have an understanding in real time what's happening in the physical world, and use that to optimize and augment our productivity. So in order to make that happen, we can already do that at some level in the 5G era. Well, in the 6G era, we will do that at a much larger scale, and that will allow us to augment our proximity, so sensing at a distance, sensing capabilities that human senses cannot have at very different frequency ranges, but then also augmenting our presence, our ability to represent ourselves or other things at a distance. Then our ability to augment our knowledge, to handle the knowledge. These digital twins allow us to understand what's happening in the worlds, simulate possible outcomes, anticipate needs, and then also decide on actions to take back into the worlds. Actions that allow to offload humans from the mundane tasks. Think mechanical tasks that machines are better at, but also inspection tasks like scanning thousands of images at a second and recognizing faults or doing image recognition. So offloading humans and leave machines to do what they are best at. But that is
workflow, right? There are many good things about machine learning when we consider workflow and offloading mundane tasks. But it doesn't stop at these things, which is the problem. It creeps into every aspect of human life, human behavior, and even human bodily functions, right? So the general pop might see this and look at, oh, this sounds great. What are you talking about? No, it gets much deeper than just this. This is the surface. This is just showing you how 6th gen is going to augment human potentiality industrially. But it goes much further, and I'll be showing you plenty more, trust me. But we got to start at the basics so we have an understanding of what this stuff is and how they're rolling it out. And what are the sales points, right? What are the sales points?
At the same time, also augment humans and let them do what they are best. So that means learning, solving very complex problems, being creative, and taking care of each other.
It's so corny. They're just so optimistic about this. It's absolutely insane. How do you even gather that conclusion from, efficiency? As if making things more efficient is just going to make the world better. It's like applying a mechanistic view to a very subjective, emotional, human kind of view. It doesn't make any sense. It's like oil and water. Wild. And again, who's going to be using this type of technology? People in industries, right? People in power of technology. The general population is going to turn into complete drones, vegging out on endless spigots of content where they don't leave their quarters, their box. That's what they're not telling us. They're saying, yeah, everything is going to be done for us all, and everything is going to be so efficient and scalable. What are people going to be doing every day? Wall-E is going to become a reality indeed.
And these are typically then also the things that we mostly enjoy. So to make that future happen, 6G will become the essential infrastructure. And for 6G, for that network infrastructure, we have identified 6 research vectors. So first is the AI/ML native air interface. The second is new technologies for radio, in existing spectrum and in new spectrum.
That new spectrum will be terahertz band, and they're slowly trying to move into that. But there's a lot of problems. There's a lot of atmospheric issues that are, in a sense, roadblocks or obstructions to rolling out a full-fledged terahertz band system, which is good for us because it's slowing down. It's slowing things down, but something to consider that this is the direction they're moving towards. I'll be showing you guys more terahertz tech too as well.
Radio not only for communication, but also using...
Yes, 5th gen is still rolling out. Well, right now they're at 5+ for those that have been paying attention to the symbols. They're at 5+ right now. There's 6th gen technologies. Infrastructure is still being designed. So right now we're at the tail end of 5th gen at 5+ right now. Moving into 6th gen, it looks like we will probably see the first implementation of 6th gen technology probably in 2026, late 2026, 2027. It all depends on how 2025 goes. But as far as the research, it's ready. Like, it's ready. We just need the infrastructure, and they're going to have this stuff up and running, man.
So first is the AI/ML native air interface. The second is new technologies for radio, in existing spectrum and in new spectrum. Radio not only for communication, but also using the ubiquitous availability of radio as a sensor, a network as a sensor. And when we start sensing the world, we also need to trust what we communicate over that infrastructure, what we are sensing over that infrastructure.
Exactly. Hence the importance of trust. As I said years ago, the 3 main ideas moving forward in this transhumanist future will be safety or security, security, access, and trust. Key human, let's say, issues where we're going to be dealing with.
Infrastructure. Given the different use cases, we will also have extreme connectivity in an architecture that is pretty much a network of networks, where the endpoints are again a subnetwork with very specialized requirements. And then last but not least, also an important architecture innovations, cloudifying and disaggregating, opening up an enormous set of new possibilities in architecture design.
run this back here. So AI ML, AI machine learning air interface. So we think of Prince of the Air, right? This is new types of systems that go beyond Wi-Fi, right? Where we get into Li-Fi and frequency networks. We'll be covering some of those, as well as biodigital systems. New spectrum technologies, that's terahertz. And then network as a sensor. Okay, so everything has some ability to be accessed remotely. Everything. Security and trust, of course, right? We have to be able to trust these systems, and they have to be secure such that we can use them. Again, for me, this is just extreme codependency, man. Autonomy out the window once this stuff is set up. Everything is contingent. You want access to some vital information or services, you got to follow protocol. And of course, extreme connectivity. This is, I call it hyperconnectivity. This is where everything is accessible. Any little bit of information, whether it's in your body or if it's in your mind, right? Once they get to that brain chip point. And then architecture innovation. So full on a revolution on systems technology infrastructure. Okay, so we're talking about stuff we've seen in Japan, stuff we see in Dubai coming to the West, but at a grander scale. And again, a lot of this stuff is still in, proof of concept. Some of it hasn't even reached proof of concept. It's still in the very early stages considering infrastructure. But the point is, billions of dollars is going into this stuff, guys. So you know they have it ready to roll out.
And then last but not least, also an important architecture innovations, cloudifying and disaggregating, opening up an enormous set of new possibilities in architecture design. So let me go through them one by one. So here first about the native AI/ML air interface. So what is the problem that we're solving? We want to have a communication between A and B over a channel, and through decades of engineering we came up with the well-known model of transmitter and receiver with the front end, the modulation, the coding, and then the scheduling of the MAC. And we're using AI/ML already in 5G to basically optimize these different functional blocks. Now, what we're trying to do in 6G is take a clean slate, do away with the complexity of these different functional blocks, and just let the two endpoints in real time figure out how to communicate with each other. And you see how that significantly reduces the complexity of these layers, how that is also a paradigm shift on how we design radio interfaces. And
again, this will be relying on terahertz band, okay? So we're getting away from megahertz, we're getting away from RF technology and moving to a completely different frequency, which has serious implications, not just regarding communication, but possibly the way our bodies function in our environments, because they don't really, clearly, they're not paying attention to the biological consequences. When we look at bioengineered foods, they're not looking at the level of nutrition and how the body is going to accept that. I personally believe what we will see is a lot of biological rejection. We biologically will reject a lot of these technologies, and that will be through, unfortunately, probably the presence or at least the expression of disease and symptoms. And if y'all paying attention, and I've showed you several papers on this, 5th gen technology does cause certain types of symptoms that are identical to FLU. Just putting it out there. I've showed you the papers. It exists. We're in the dark about a lot of this stuff because it's being forced on us. A lot of these new frequencies and these new technologies, level of hyperconnectivity, we're already seeing the fallout socially. Just this hyperconnective algorithmic capture, all of these things, we see how it's messing with us socially. Recently, I was with some friends, some groups, and some families, and a bunch of kids and stuff. And I'm telling you guys, I could not believe the level of screen addiction. These poor children. I'm talking like the majority of the time, not out playing. There was a few of the kids out playing, but the majority of these kids, man, and I'm talking like under 12 years old, okay, just totally stuck to these phones on TikTok. 8-year-old kids on TikTok, just it was so disturbing, man. You know, I can't tell people how to raise their kids, you know, and that's just not my position. But just seeing it hurt almost, man. You know, it made me sad, you know, especially when I look at my family, and we don't have no devices, okay, for nobody getting a device, period. All right, so just seeing the stark difference in child behavior. You know, in one way I was proud, in the other way I was depressed, you know, thinking about the future and like, what the hell is happening here? What is happening? Right? So if I already see the younger generations totally plugged in to the point where they're socially different, they're engaging and relating to other people in a whole new way, right? It's very muted, right? It's very, what is this? What's the term? It's splintered, right? In my book, I write about splintered attentional states where we're constantly processing and dealing with information at once from different places. So we might be thinking about social media, thinking about some piece of content while speaking with somebody, and even engaging on a phone while speaking with someone. It's this another type of distributed cognition, right? But our attentional states are splintered. This causes all types of anxieties in the background. This causes all types of cognitive load that end up, as an outcome, having all types of, you know, symptoms, you know, foggy headedness, anxiety. What is it? Agitation, when people are when people just seem to be agitated easily, right? It's because we're just having this influx of data. Anyhow, seeing these kids like this, man, and then considering this future of 6th gen tech and these ubiquitous computing environments, and the young people are already giving themselves to the machine through data. It's hard to not consider the fact that we might be moving to a type of real deal Wall-E / idiocracy / what is it, body snatchers, Attack of the Body Snatchers kind of scenario. It's creepy, man. It's so creepy. And I'm partially fascinated by it, but also extremely concerned. So I make it a very important part of my work to really dig into this stuff. And I'd like to dig in more. I don't want to be too nerdy with it and boring, because there's so many papers I'd love to just sit and go through with you guys. And maybe we will, especially on the Patreon and Locals. We'll do that here, because this stuff is getting more weird, man. And as we get all of this political stuff and psyops going on, man, these technicians and engineers in the background are pumping out crazy tech, man. And it's all being slowly built up around us.
We've done already first experiments in that new space with native AI ML air interfaces in Bell Labs. You see here how how the AI ML air interface self-learns the constellation depending on the channel conditions. Then new spectrum technologies. So first of all, new technologies in the existing bands, the low band, the mid band, and the millimeter wave, that will be refurbished for 6G, as we can expect. But there will also be new bands. We already talk a lot about using sub-terahertz for 6G. There's a lot of...
There we go. Sub-terahertz. 7G is terahertz, right? 6G is sub-terahertz. As we move into completely new frequencies, that will change how we operate. It will change us biologically. It will change our biological / environmental relationship, because we know how important frequencies are. You know, electromagnetic fields, what have you. They're playing with fire, in my view. Playing with this level of, let's say, environment and element. This is playing God, right? This is playing God. We weren't built for this type of stuff, and there's going to be a rude awakening, unfortunately.
Research going on, high capacity and unique sensing capabilities, and I'll get to that in a minute. But there's also a drawback. I mean, as you can see from the lower scale, the reach of those sub-terahertz wavelengths is limited to 100 meters. So it's really confined to indoor spaces. Another important use case or spectrum are the bands just above the current midband. So from 7 to 20 gigahertz.
I think I said megahertz earlier. I meant gigahertz, my bad.
Which provides us with bandwidth comparable to millimeter wave, but with a better reach. So say more than 0.5 kilometers, allowing us to do a capacity enhancement from existing cell sites in urban environments. And then we can also expect that in the low band there will be additional bands to also address the wide area coverage over multiple kilometers. So as already said, these new spectrum technologies are not only there for radio communication, but we want to look more into using the ubiquitous radio infrastructure as a sensor. Already today, we are able to do localization with wireless technologies. And you see here a proof of concept that we have built in and have tested in Arena 2036. That is an experimental factory in Stuttgart, where we use 5G for the tracking and localization in real time of a robot. And we can do that with 10 centimeter accuracy. Now, going to 6G, with the wider spectrum, with the higher frequency and the narrower beams that we can form, we will have a much higher precision. And it's not only localization, but using it as a radar, it will also give us volumetric information.
Man, can you, volumetric, they'll be able to understand space and time, proximity. And listen, it's not just about objects and products and services like with the circular economy. It's human bodies too. It's human presence. This is Orwellian when you really dig into it. It's like, wow, there will be no way to hide from this type of stuff, man. No way to hide.
And there are material-specific back reflections that we will be able to use. Is it a metal surface? Does the body contain water? Is it a mammal or a human? So combine these sensing informations with also AI/ML, and you create a radio network with a sixth sense.
Sixth sense, wow, interesting.
So staying with the industrial automation, we will also boost the requirements there, looking at the extreme networking where the endpoint of a network is again a network. Think machine area network, think a car area network, think a body area network.
Body area network. We've covered this, we'll return to it.
And within those area networks, you will have very extreme requirements, sometimes life-critical requirements. You don't want the brake of your car to fail, 9 reliability. And the response times need to happen also in a factory within hundreds of microseconds. And synchronicity will be even in the nanosecond range. So network of networks with very specialized requirement in specific subnetworks.
Again, relying on massive network systems of frequencies, relying on machinery, AI, that is vulnerable to glitching, vulnerable to hacking, vulnerable to just basic error. In fact, when you look into the terahertz band and some of the technologies they're producing, just weather, just aspects of the atmosphere, elements within the oxygen we breathe, wind, trees, hence terraforming the environment. Elements within the environment are obstructive to these frequencies and these network systems. For instance, if a tree falls down, it's going to cause some type of rift effect in the frequency. Birds in the air flying around cause some level of obstruction or disruption to these connective waves. So imagine something goes wrong, like it could create complete chaotic scenarios on a grand scale when industries, vehicles, like when we get these automated vehicles that are running on these systems, or when people have biological machines in their bodies that are doing certain things to keep them alive, right? Imagine when there's issues with the frequencies, with the network connections, and things go wrong. I mean, it's just the level of error and fallout and chaos, in my view, are very high. It's very, very probable that more negative outcomes will occur opposed to all of this pie in the sky abundance and efficiency.
And then another important architectural theme is also the disaggregation. We have already the paradigm shift to Cloud RAN that we see in 5G with O-RAN. And we have already first prototypes where we virtualize not only the core, but also the radio access network, and where we do the physical layer processing on common off-the-shelf hardware like a GPU. And we can expect new accelerators, new types of XPU processors emerge in future, and also AI ML accelerators. And so this allows us in a flexible way, thanks to cloud native design principles, to instantiate RAN functions like the distribution unit, the centralized unit, or the core unit on a slice-by-slice basis, scale them on a slice-by-slice basis, and optimize their location. So that's already in 5G, but the microservices approach actually allows us to do a lot more. We can now think of dissecting the RAN and the core functions and have a fresh look at the partitioning and the architecture and optimize the location and the functions themselves on a need-by-need basis.
So this is a great look. He's presenting just the cloud aspect of the architecture and ending in their goal, which is edge computing. We've covered edge computing in the past. It's just a type of decentralized, hyper scalable networking that we don't have now. We don't have the capability of it now. But once they acquire these new edge computing clouds, I mean, they'll be able to run like I'm talking like high level, let's say computer power and processing everywhere and anywhere. And see, the problem with this edge computing is it's going to make things so cheap and in many cases free and abundant as far as content and data or media is concerned. So the general population is going to really love this stuff because things will just be a lot more affordable and we'll have a lot more in general. But again, with that comes more connectivity, more detachment, but also more the relinquishing of autonomy and personhood. Like our personal lives will now be fully transparent in these systems. That's the part that's hard to accept, you know, because this is a part of the future where it's like, well, we got all these great things, but guess what? You guys got to turn into these like little drones now, and it's just hard to deal with, man.
And then last but not least, the security. As the number of devices increases, as the number of networks, subnetworks increases, the fact that we have open interfaces and have components from different sources, the fact that functions run on a heterogeneous cloud, private cloud, public cloud, web-scale cloud, and that within those data centers we have software from open source, from multi-vendors, we have different updates, patches, so an enormous surface of potential security attacks.
There we go. This is one thing that pisses me off the most about these insane psychopaths, and I'll say it, is the level of vulnerability they're creating with these systems. Vulnerability for the people, for the plebs, those of us on the ground level. As these people sit in their, you know, their ivory towers, controlling the world, its resources, its environments by their technologies, we deal with the fallout. He said it here. I've said it many times in the past. The higher the connectivity, the higher the level of vulnerability, which equals the higher level of security that's required. Pure transparency. Human as pure information, pure transparency. All information has to be given up. He doesn't use the term, but the term is called zero trust. That's it. Zero trust architecture. Zero trust meaning no data is left behind, right? They want everything. That's why we're seeing even YouTube asking for all kinds of personal information just to run your, just to put links, just to pin comments. You have to give up some biometrics now. Yeah, it's ridiculous. I'm dealing with it right now. That's why you can't click my links on the main channel. I can't pin anybody's comments anymore because they're asking me for all this crap, and I'm not doing it. I'm trying to find some way around this stuff, man. This is just crazy to me. You know, I'm gonna be showing you guys something shortly here once I finish it up on biometrics. A lot of these new biometric developments, and it's crazy because I see all the websites following suit with this, YouTube included. They're all prepping. They're all building the infrastructure. It's like, damn, man, this is moving so fast. And it's crazy because the politics are heavy right now. And it makes sense because they're about to roll out this Skynet. This is Skynet right here. All these 6th gen cloud tech, all this stuff. This is straight up Skynet, man. Like eye in the sky level omniscience, omnipotence, omnipresence. It's pretty wild, man. But security, this is the thing. You want all this connectivity, you want all the bells and whistles, you want all the cool devices, and you want everything efficient and, you know, convenient. Y'all want all of that stuff. But yeah, you're gonna have on like some real austerity, some real deal authoritarian type of security, zero trust architecture.
With that goes also the use of AI/ML with its own security risks. So we need to address that in new ways, and we need to design security and trust into a zero trust infrastructure.
There he goes. Okay, he said it. Wow, that's crazy. I didn't get through this whole video. He actually said it. Damn, they just coming out with it now. Straight up.
From multi-vendors, we have different updates, patches. So an enormous surface of potential security attacks. With that goes also the use of AI/ML with its own security risks. So we need to address that in new ways, and we need to design security and trust into a zero trust infrastructure and design these concepts from the ground up in 6G. So hereby I'm reaching the end of the talk. So it is about all about augmenting the human capabilities, for which the 6G infrastructure will be an essential network. And I talked first about the 6G era application, so connecting the worlds, the physical world and the human worlds with the digital worlds. And then also the 6G technologies, of which we have 6 research vectors.
So this was a very important little vid here to demonstrate some of the basic biodigital industrial applications. Now, as we continue with this transhumanism intro lecture series, I'll be going into the biological applications. And as you can see here, there is a brain right there in the background that he didn't even talk about. But that brain, if you pay attention, that brain is there for a reason, because the ultimate goal is to fuse human cognition with these industrial machines, right? At scale, industrially controlled. So they will be managed via these corporations, man, by these technocrats. Imagine, right? It's absolutely insane. It's so insane that, but again, this is an industrial movement. This is about industry. It's not about humanity. It's about changing humanity with industry. And this is essentially a transhumanist effort. And I know transhumanism is thrown around quite a bit today. It's a popular topic, but if you're here, you know, I appreciate you, and we're definitely going to dig into it at a much deeper level and flesh it out, because it's a pretty complicated topic. it's really about post-humanism at the end of the day. Transhumanism is literally a transitional period of time. The real problem and issue is the post-human and the post-human era, which we've been talking about quite a bit here for those that have been keeping up with the series. So, yeah, I wanted to go over this. I thought this was really important just to present to you the next stage of industrial, how can we say, networking, okay, opposed to just what we're used to, this kind of 5th gen tech that's pretty, came out in 2019, right before the COVID, right? So, I don't got to explain it. But next couple of years, they will be rolling out the new 6th gen tech. So I wanted to give you just a little briefing on this. So as I dig into deeper research papers and deeper videos, you'll already have an idea of what some of this stuff is. And we've talked about the digital twins in the past, so now you understand the digital twins with the 6th gen application, how it's going to be used industrially, etc. And some of the components, AI, of course, cloud computing, new frequencies, security, architecture, etc. So I got to get out of here. I'm getting ready to go live again with Mo Fax and Brother Hulk. We're going to talk about this whole Kamala situation on the not on this channel, but on the Dawn TV backup. So I'll see you guys over there. I just got to get that fired up here about an hour or so. So I appreciate you guys, all the patrons and locals. Thank you for being here for another edition of the lecture series, Introduction to Transhumanism and Cybernetics. And we're getting closer to the cybernetic research as well. That's going to be interesting. Got a bunch of cybernetic history and technologies to integrate with this understanding as well, where we will be returning to the philosophical aspects of transhumanism. We left off with the image of man. We have another lecture where I'll be digging right back into the philosophy. So we cover in the philosophy, we cover the technology, and as well as the social issues, right? Social / psychological that become cultural, right? So I appreciate you guys. I will see all of you very soon here. Peace and blessings to you all.